So we use the binomial theorem and Pascal's triangle together. So our triangular pattern of numbers, you start with a 1, and then you have a 1 and a 1, and then you add. So the outside is always 1. You add these two together to be 2, and then you have a 1. So the outside is 1. What's 1 plus 2? 3. 3, 1. So the next one would be 1, and then this would be 4, 6, 4, 1. And you go on forever. Excuse me. 1, 10, 10, 5, 1, and so on. This is called row 0. Not row 1, row 0. This would be row 1, row 2, and so on. Okay? So Pascal's triangle can help us with the binomial theorem, but we actually don't need it. Some of you will be able to bypass Pascal's triangle and go straight to the binomial theorem. All right, so the binomial theorem, we're going to use that to expand, and what I'm going to do on this first one is use Pascal's triangle. So when a number is to the, when a quantity is to the 5th power, in the olden days, you would write it out 5 times. And then take these 2 times each other, and these 2 times each other, and whatever those 2 were times each other, then those would be take times each other, and then that. And it would just be seriously totally complicated. Then this dude called Blaise Pascal came up with Pascal's triangle. Now, if it's to the 5th power, we're going to use row 5. We're going to use row 5 of Pascal's triangle and go 1, 5, 10, 10, 5, and 1. And those are the coefficients of each of the terms. Remember when you just got done multiplying on the worksheet you're working on now, you found that there were coefficients that were happening. Okay? So those are the coefficients that we're going to have. Now, when we use a binomial theorem, the first term we start out with the highest power, and the last term we're going to start out to the lowest power possible. So the highest power of x possible is going to be to the 5th. The lowest power of y is going to be y to the 0 power. Okay? And when there's addition, it makes life really nice. There's just going to be addition for each of these. All these are going to be added together. Okay? So it's 1, x to the 5th, y to the 0. Then it's going to be 5. And then we drop the power by 1 on the x. And we add a power by 1 on the y. Drop a power by 1 on the x. Add a power by 1 on the y. And keep the pattern going. Now, I got to simplify this just with one tiny little thing. Okay? What is anything to the 0 power? 1. So what is 1x to the 5th times 1? 1x to the 5th, right? Or just x to the 5th. Plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. So if you multiply this times itself 5 times, which would be horrendous. Trying to keep all of that straight would be horrendous. the binomial theorem saves us oodles and oodles of time. Okay? Oodles. There we go. Okay? So that's how it works basically. Okay? That's the basics of how it works. Now, we were lucky here that it was addition, so we didn't have to worry about signs. We were lucky here that this is just 1x to the first power and 1y to the first power. But is that going to be the way it is all the time? No, of course not. This is algebra. We got to make things a little bit difficult. You know, got to work your brains a little bit here. So, binomial theorem, how are we doing? We almost have that written down for most of you, right? Okay. So, x minus 3. Ooh, we have a number now. Now, we're going to use row 3 of Pascal's triangle. Okay. So we go up, row 3. What does row 3 look like? 1, 3, 3, 1. 1, 3, 3, 1. So I'm just going to write 1, 3, 3, 1 just off to the side here to help us out. Okay? So it's going to be 1 x to the what power? Third, the highest I can go. And then negative 3 to the what power? 0, the lowest I can go. Highest, lowest. Then I'm going to put a 3 down. X is going to be to the next lower power, so x is going to keep going down. 2. And then negative 3 is going to be to the first power. Plus 3. X is going to be to the first power. Negative 3 is going to be to the second power. Plus 1. X is going to be to the 0. Y is going to y. It's not a y on this problem. 3 is going to be to the third power. Okay? So simplify. What's anything to the 0 power? 1. So 1 times 1 times x to the third is just x to the third. Here's where the negatives come in. Negative 3 to the first is negative 3. What's negative 3 times a positive 3? Negative 9x squared. Okay. What is negative 3 to the second power? Positive 9. Good job. It is 9 times 3 is 27. X is to the what power? First power. Plus, that should be a negative 3. Forgot my negative sign there. So negative 3 to the third. Negative 3 times negative 3. 9 times negative 3. Negative 27. X to the 0 is 1, so 1 times negative 27 is a negative 27. I'll get rid of my plus. Minus 27. So if you would multiply out x minus 3 times x minus 3 times x minus 3, you'd get x cubed minus 9x squared plus 27x minus 27. Okay. Now, some of you might have Pascal's triangle fairly memorized, but even myself, once we get to the 5th row, I got to look at it. It's just plain and simple. I've got to look at it to make sure I've got it down. 5th row, 1, 5, 10, 10, 5, 1. So I'll write 1, 5, 10, 10, 5, 1. Okay. This time we have a power to deal with, which you got to be careful with, and you'll have to take powers to powers. So, first term, 1. S squared is to the what power? 5th. 3 is to the what power? 0. Plus, and with it being plus sign, makes life easier because we don't have to worry about the negative sign. Plus 5, s squared is to the fourth, 3 is to the first, plus 10 s squared to the third, 3 to the second, plus 10 s squared to the second, 3 to the third, plus 5 s squared to the first, 3 to the fourth, plus 1 s squared to the 0, 3 to the fifth. Okay? Binomial theorem. Once you get the pattern down, it's really not that difficult. You just have to work with the patterns. Okay. 3 to the 0 is 1. Here's 1. 1 times 1 is 1. Power to power, we multiply. So it's s to the 10th power plus 5 times 3 is 15. S is to the 8 plus 3 squared is 9 times 10 is 90. S is to the 6 plus 3 cubed is 3 times 3, which is 9 times 3, which is 27. 27 times 10 is 270. S to the fourth plus 3 to the fourth. 3 times 3 is 9 times 3 is 27 times another 3. 81. 81 times 5 is 405. S to the second plus 3 to the fifth. So then if this was 81 times another 3 would be 243 times 1 is 243. S squared to the 0 is 1. So it's just 243. Straight. Okay. There's a black one. Open the big cabinet. There's a black one. Yep, open bottom door, left door, black one. Does it have a number on the back end? Write that number down, or just what is that number? Drake is 116. Okay. I'll write it. I don't give out charges because I need them for my people in the class. So when you need to charge, bring it in and charge it for on class period and then take it again. Yep. Okay. All right. So we're going to jump down to like this one. Okay. Now, do you have to do the whole thing here? No, you don't. What's the second term of this? Well, this is to the 6th power. So if I just did 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5, 1 for the 5th power, then this would be 1, 6, 15, 20, 15, 6, 1. The second term, all I need is this one. So it's 6, okay? If my first term, I take the first one to the 6, my last one to the 0, my second term would be the first one to the 5th, my second one to the first, okay? This is 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6. Okay, see how that works? So then if I'm just finding the second term, 2 to the 5th, 2 times 2 is 4 times 2 is 8 times 2 is 32. So 6 times 32, c to the 5th, times d. 6 times 32, 6 times 30 is 180. plus another 12 is 192. C to the fifth D. Boom. Second term. Okay? Pascal's triangle and the binomial theorem. Okay, the last thing. Okay? Well, this one, let's look at this one really quick. How many terms are there? Well, when we do Pascal's triangle, for each row that I have, row 0 has 1 term, row 1 has 2 terms, row 2 has 3 terms, row 3 has 4 terms. So, zoom, zoom. If I have the ninth power, I have how many terms? 10 terms. That'll be the easiest question on the quiz. Okay? If I ask you how many terms there are, it's always one more than the power. Now let's go here. Last question, because I know this might be a quiz question as well. Your quiz is on Friday in here. Your quiz will be on Friday. You'll get a review packet Wednesday. So if you're gone Wednesday, make sure you get a review packet from me. Okay, expand this. What is the sum of the coefficients? Okay, this is not super hard, but we do have to do the math. Okay, so where do we start out? Well, the fourth row, we should have 5 things. Oh, I got to go look at Pascal's triangle really quick. Fourth row, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. All right, so first term. 1 times 2x to the 4th times negative 1 to the 0 plus 4 times 2x to the 3rd negative 1 to the plus 6 times 2x to the 2nd negative 1 to the 2nd plus 4 times 2x to the 1st times negative 1 to the 3rd plus 1 times 2x to the 0 times negative 1 to the 4th. All right. It says, what is the sum of the coefficients? Do I have to worry about the x's? No, it's not a coefficient. Negative 1 to the 0 is 1, so I don't have to worry about that. Don't have to worry about that. 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16 plus 2 to the 3rd is 8 times 4, which is 32. But this negative 1 plays a part in this. It becomes a negative 32. 2 times 2 is 4. Times 6 is 24. What's negative 1 squared? 1. So that cancels out. 1 times 24 is just 24. Negative 1 cubed is a negative 1. So that'll make this part negative. 2 to the 1st is just 2 times 4 is 8. So it's a negative 8 plus 2 to the 0 is 1. Negative 1 to the 4th is 1 times 1 is 1. So 16 plus negative 32 is negative 16. Negative 16 plus 24 is 8. Minus 8 is 0. Plus 1 is. After all that, what's the sum of the coefficients? 1. Okay, so you'll see problems like that. This one is on Sabbath. So I'll put that out. It'll be on Google Classroom. Some of you love Sabbath because you can redo the problems and make sure you get them right. Some of you hate Sabbath because you just hate Sabbath. I don't know why you hate Sabbath so much, but some of you do. But there you go. Let me finish the recording. Boom, boom.